In this video, I'm going to show you how to calculate Cronbach's alpha, and it's really actually not that hard. It's more hard to understand what Cronbach's alpha is telling you. So remember, we're trying to get the reliability of some scale, and we don't have the time or resources, or we just are lazy, and we don't want to get the retest reliability. We don't want to give someone the test and get the whole composite score for a whole test and then give them a test again sometime later and then get a composite score and then correlate those two composite scores. We just don't have the time or money, or we don't want to, or people won't let us, or whatever. We can't do it. So we are trying to estimate what the retest reliability would be based on the inter-item correlations, and that is the correlation between two items at a time. So we get the mean of the inter-item correlations, and then we plug it into this formula that we have here. Okay, and I will show you that in a second. So here we have a correlation table. This is normally what we will have. So we have 3 items for this example, and so the correlation between item 1 and item 1 doesn't make sense, so that's why it's not there. Between item 1 and item 2 is 0.33, and then the correlation between item 1 and item 3 is 0.32, and the correlation between item 3 and item 2 is 0.29. Okay, so we're correlating each item with another item, and we do that for all possible correlations that we could do. So the ones that aren't in this are just repeats or correlations with the same item which don't make sense. So we're not going to repeat this part right here because that's a correlation between item 1 and item 2, which we already know is 0.33. So we're not going to repeat it. That's why there's missing kind of data in this table, but we don't want to repeat anything. So here we have the mean of the correlation. So I'm going to use Ri as the inter-item correlation, and we're just going to find the mean of them. So I'm just adding 0.33 plus 0.32 plus 0.29 and divided by 3 because there's 3 of them. And we get 0.31 as our average or our mean inter-item correlation. So remember, these are called inter-item correlations. So we're getting the correlation between items. That's why it's called inter-item correlations. Okay, and here's our formula from Cronbach. Just showing you it again. Now I'm filling it in. So K is the number of items. So K, number of items. Then we have the mean inter-item correlation. So that's 0.31, and we got it from up here. And then that's also here in our formula. And then we also put K here, which is the number of items. Okay? Then the next thing we do is we're going to do the top first. So if we times K, which is 3, times the mean of the inter-item correlation of 0.31, we'll get 0.93. So just did the top first. Now we're going to work on the bottom. But remember, we want to do the parentheses first, then exponents, then multiplication, division, and then addition and subtraction. So we're going to do inside the parentheses first. So we're going to do 3 minus 1. And we get 2. Now we're going to work on the multiplication. So 0.31 times 2. which is 0.62. And then we're going to add and get 1.62. And then finally, when you get the top and the bottom done, you can think of the top and the bottom in separate parentheses. But when you get the top and the bottom done, then you can divide them. And so we get 0.57 as our Cronbach's alpha. So this example was with 3 items. Now let's do it with 10 items. So now we're going to go over an example with a 10 item scale. And I have already calculated the mean of the inter-item correlations for these 10 items. And you can see this in more depth for the homework later on, none of the videos. But anyway, so the mean for the inter-item correlation is 0.31 still. But now we have 10 items. We have the whole Rosenberg self-esteem scale instead of just 3. And we're going to see what happens to Cronbach's alpha. So we're going to use the same formula from before. So now we have this formula, and now we have 10 times the mean of 0.31, and then at the bottom, instead of 3 minus 1, we have 10 minus 1. So we're going to do the top first and do 10 times 0.31, and that gives you 3.1. Then we're going to do the bottom, and we're going to start with parentheses. So we're going to do 10 minus 1, which is 9. And then we're going to do the bottom multiplication, 0.31 times 9. We get 2.79. We're going to add 1 to that. And then we get 3.79, and now we can divide those numbers. So 3.1 divided by 3.79 is 0.82. And so if you remember from before, the retest reliability for the Rosenberg self-esteem scale, the 10-item one, after 2 weeks is 0.85, and after 7 months is 0.63. So this has been shown before. And so you can see that this estimation of the retest reliability based on just one administration of the test is about the retest reliability of the 2-week period. So in this case, it did pretty accurately predict what the retest reliability would have been if we gave the test twice. But we only based this on the internal consistency of the test, not about having 2 tests and correlating them. So this was just an estimate, and in this case it ends up working out well. But that might not always be the case. But at least for the self-esteem scale, the Rosenberg one, it worked out pretty well. So what we calculated was based on one time period, one testing, and it predicted pretty well the correlation between giving the test at time 1 and giving the test at time 2.